All right, this one, set up SIGROC to look at I squared C. Went pretty well. Honestly, the protocol decoding is really nice, and so I originally wanted to get it talking to a scope and do that, but ended up buying a DS Logic Pro to do the capture, and that works pretty well. I mean, you can read it fast enough that there's no issue, and it's just really easy to do. So that was pretty good. I did have to go for the nightly build for some reason, and so that was pretty easy to set up if you've never done that before, especially on Linux. Well, on Windows you just download it. On Linux, you for configure scripts you can specify a -- prefix, and so I typically do that in .local on my home. That works really good. And there will be environment variables, or so in some of the better made packages it's like there's a program called package-config, and you can specify package config dir, which will be into that .local. So you do configure with the prefix for like the base libraries where it can pull in the system stuff. Then you do make install, and then that library is in your .local. Then on subsequent libraries you do package config path, or there will be a define for each specific location of the dependencies. That's typically used more on a Windows build, and you pass that to configure with the prefix. You do that, and so that's what you end up doing for that. For Pulse View, which is the program that actually displays it, that's a little easier. CMake, a lot of people hate CMake, but having approached it from the other end, finally, where you're trying to package something for multiple operating systems with a lot of libraries on a lot of distributions, CMake is like this black hole you just throw yourself into because everybody else did it, and it's easy. And so for that, you end up setting some variables. On that, it's like a D option. You're like, yeah, you set package config path. Yeah, hold on. Yeah, you set the package config path before CMake, then you do D CMake install prefix to your .local. And then in your bash RC, you'd like import your .local/bin. There's occasionally issues where stuff is like, it'll just be like /share, like if you had a share directly on your root file system, which I've never seen. So it is a little messed up, but it's generally pretty good. And one of the interesting, so I'm doing work with a BQ4050, and one of the interesting things is the manufacturer block mode commands don't work. So there's a lot of commands where you write the address, you write the thing, and then either write or read a response from it, and that'll get you access to the protocol commands for the smart battery system. There's a command 44 in hex that does a block mode for reading more advanced stuff, like you can do device attestation with SHA1, and you can set up the key material for that. You also set up like the design capacity, so you have to tell it. I mean, it detects if there's 4 cells, but the cells can vary within some parameters, and I guess you can set the chemistry and stuff. I forget if this one's specifically for Li-ion or LiPo. But that doesn't work, and what's interesting is you get an ACK, Yeah, so you write the first bit, and this is all, you know, I wish I need to work on my setup. I'll probably re-record this and go over again. But you write the data bit. This SN bus device cares about the start and stop bits, so you have to, both of them start high. If you don't set the continuation flag on your API, what will happen is at the end of the address byte, or the address bytes, it'll go up again, and it'll like forget that you were doing something. So you need to hold clock low, and then it sends you an ACK, and you send the next stuff. So basically what happens, you send the address byte, you send 44, then you send oh, I just saw it. Hold on. I don't know how I glossed over this. I'm sending the address byte twice. That's the issue. It's sending the address byte twice. Was it doing that the first one? I didn't expect to do this live, but is it sending the address byte? I'll need to I'll need to check that. But I'm pretty sure it was doing something else. You'd send the first one, and then you'd get the 44. It'd send the 54, which is the battery status or something, and then it would send you a NAC. And then you can go ahead and read. You read the 5400 back, which is right, which says it did something. But then the rest of it you get zeros. You don't get any real data. And that's the thing that confounds me, because it's actually echoing you. So if I change out 54 as operation status, which tells you the security mode, like if the device has been sealed, if I do any other command, I get it echoed back. But I get a NAC after, you know, I send OX16, 44, there's a gap, which is clock stretching on the device side, I think. And then I send 54, clock stretch, NAC. So as far as I can tell, it's the device that's aborting. And there's not really anything in the embed API I can think of. I had similar issues when I used the STM32 HAL, so I might take a break, go back to that. That can be a little easier to read through. It's not great. I prefer embed because it usually just works. And yeah, here actually this will be pretty quick. So I was playing around, making sure it wasn't something super weird. The other thing I need to fix is half the time these things, not half the time, not that bad, but a lot of the time the devices will like hang, and I don't have a good way to fix it. I have to unmount it, replug it, mount it back up. So let's see, I send 44. Yeah, I send, then it clock stretches. I get an ACK. I send 54. Clock stretches. I send a NAC, but I've got another byte queued up to read. So I don't know about that. And trying to get help for this, it doesn't always work out really well. I mean, a lot of places like Texas Instruments E2E forums, I haven't asked like I got told to read the SN bus documentation, which I have, and there was some other article I read. It's like, you know, you get 10 I2C devices and you put them on the same bus. It's likely you're going to have an issue because there's just various peculiarities in how they're all implemented that cause problems. The ACKs and the writes, that's like that is a really, really small. Let's read it 20 megahertz, I guess. Run. Knack. Oh, that's funny. I get a knack on the last one. Alright, am I... Well, I wasn't really missing much. It's nice. Yeah, wow. Yeah, not a lot more to say on this, but I'll need to follow up on it. So, cut out some of those pauses.